Good morning, everyone. I hope you guys are having a wonderful Thursday to my colleagues in the US. My name is Riaan Nolan, and I'm a HashiCorp ambassador, and I'd like to take you through what I think a good Terraform developer environment looks like. But before I start off, I just want to give a quick shout out to our language interpreters. I am just simply amazed at how quick they translate this complex technical language into sign language. It looks so professional, and I just want to say thank you very much for HashiCorp for also including our dev colleagues. So I just locked my screen, and what I'd like to do is I'd like to share my slideshow with you. And what I'd like to do is click on the present button, share screen. I wonder if I can share this screen. There we go. There we go. I think you guys can see my screen at the moment. So first off, I'm in my business life, my work life, I'm a consultant, which means I work for very many clients. And these clients have teams of various capabilities, maybe small teams or larger teams, and they're at various places of their infrastructure as code in their cloud journey. With the effect that sometimes I work on a Windows laptop, sometimes I work on a Mac laptop, sometimes I work on an RDP Windows instance, and I do not always have administrator rights on these systems. Now, what that entails is that we need an environment that is easy to spin up, is throwaway, has got all our tools built in, and will work on Intel Macs, on ARM64 Macs, or Windows systems, and even in our build agents. So through this presentation, I'll go through what I think this environment looks like, and some of the topics I'll cover is dev containers, code spaces, GitHub Actions, Terraform Sec from Aquasec, TFSec, checkoff, and pre-commit rules, and then Terraform Cloud integration from GitHub Actions, and then a little bit of Terraform lint and validate. So down here at the bottom next to the little star is the link to the GitHub repository. You're welcome to clone this down and follow along, and I hope you enjoy it. Now, here is some of my URLs that you can link with me on. Find me on LinkedIn. I'm also the creator of HashiCube, and HashiCube is a little DevOps lab that runs all of the HashiCorp products and has got some popular open source integrations such as AWS Tower or DBT or GitLab or Minikube and Waypoint, and it all runs in a little Docker container. So you're welcome to have a look at that. So firstly, I'm going to cover the development environment, and I'll touch on topics like dev containers. I'll show you the Dockerfile, and I'll show you how to develop locally using the VSCode IDE with a dev containers extension. Then I'm going to show you how to develop in a browser using a GitHub Codespace environment. And then I'll show you a little bit of a GitHub Actions pipeline that runs these compliance and governance checks, and then finally runs a plan and an apply on Terraform Cloud. But just before that, it will also take your modules and using a .module-version file will take these modules in a monorepo and publish them in its own little repository. Thereby, we take all of these modules in this monorepo and we create multi-repos out of all of them. And then this will then be sucked in by Terraform Cloud to be used in your private modules registry. Then I'm going to just show you a little bit of the GitHub secrets that I use to help make this. I'll take you through run.sh, and run.sh is just a bash file with a bunch of commands linked in between. that you can use to quickly run, let's say, make TFLint or make validate any of these. And TFLint obviously is Terraform lint, and validate is Terraform validate. And then secondly, I'm going to take you through the governance and compliance piece. I'll show you a bit of Git pre-commit rules, which I think is just simply amazing. And then I'll take you through TFSec and checkoff, and then Terraform FMT and validate. And I'll take you through some of the linters. And then I'll show you how I use Terraform docs to generate documentation from our Terraform code. And then I'll show you a little bit about Terraform Cloud. Then lastly, I'm going to show you this Terraform modules, library, and patterns, and how we take these modules and we scan them with checkoff and Terraform security, and then how our versioning works with SemVar. And lastly, I'm going to show you how this module is being promoted from the monorepo to its own multi-repo tagged, and then how this flows through into Terraform Cloud's private module registry. So, onboarding can take anything from an hour to a day to days to weeks. I mean, in my previous life, I was a systems administrator for a company that used a lot of Symfony projects, and the dependencies is a mile long. You know, you talk about Memcache, Redis, MySQL, syncing this database down, setting up your PHP versions, your PHP extensions. And Terraform is actually no different. Strangely enough, the easy part of Terraform has become actually writing Terraform code. But this whole meat and process around managing your code and making sure that you are safe and secure and protected can be quite a long tail. And then if you have self-service teams and these are your customers, now it becomes even more complex. So typically Terraform engineers are tasked with setting up their own environment. And like I said, they could be using Windows or Mac, could be different Macs. And for those of you who's ever built a Dockerfile and then discovered that it doesn't run on the Mac ARM architecture, will know exactly what I'm talking about. We'll also show some helpful commands using format and lint to make sure that our code is nicely formatted and looks presentable. And then secondly, I'm going to discuss this shift left component. Now, everyone uses shift left, but what this really means in production is before a developer is able to commit any code into your repository, that your code is being checked for proper syntax, trailing white space, proper line endings between these different operating systems, that there's no AWS keys or password or private keys linked in this. And if you start doing this early on in your workspace, your development process, then it will save you such a heartache and headache further down the line. So I'll show you a bit of how this works, and all of this developer environment and compliance is driven out of code. So it's an all-in-code solution. And then lastly, I'm going to show you how we use this modules library for a quality assurance, QA, plan, and apply. And you can think of this repository as kind of a buffet. So if you are into chicken wings, you can walk straight up to the chicken table, grab yourself a chicken leg and a chicken wing, and off you go. If you feel like fish, you can go straight to the calamari section or the fish section. If you want to have salad, this is a buffet, and you can completely just pick and choose and cherry pick what you want to use in your own projects. Or you can just take the whole thing as it is and start working on it like that. So enough talking. I think you guys want to see some stuff, eh? So let's get into demo time. So I'll open up this Terraform modules library of ours. And in here, I'd like to show you what a dev container is. Now, a dev container is not a VS Code thing. It's not a GitHub Code Spaces thing. supports many other IDEs like JetBrains. But what a dev container is essentially, and I think I'll just quickly open up my screen a little bit, is it will read a dev container.json. And firstly, it will get directed to a Docker compose, which I'll show you now. And we'll set a service name for this. This is your container or image name. And then we'll specify in which folder we are going to work. We can then set some Git commands if we have to in the post start section. And we can specify the extensions for VS Code that we'd like to pre-install. Now, let's look at the Docker compose file. So if we look at this Docker compose file, this simply tells us that we have a build context and the Docker file is in the current directory. We specify some volumes to mount, and some of them are my SSH keys or my GPG keys to authenticate against GitHub. And then we specify some environment variables that we'd like to call or transfer into this container once we are live. Now, let's look at the Docker file. So we're using Ubuntu Jammy. Thank you, Canonical and Mark Shuttleworth, for this wonderful operating system. And we are installing a bunch of packages, right? We're installing Tree, Unzip, Zip, Nano, Vim, and all of this DOS to Unix stuff and everything. And then we are setting some environment variables. We actually are installing these packages that we specified up here. And then we are creating a user. And we are installing some of our dependencies. So lint will check our Dockerfile, warn us if there's anything that we should be alerted towards. Then we copy our TFEnv file in there, in here, and we install TFEnv. And basically what Terraform environment does is we specify our Terraform version in code, and this will be automatically installed for us. Now, the same with our Terragrant. We will specify our Terragrant version, and this will be installed. And although I don't use Terragrant specifically for this environment, what you can do is you can create a .terragrant HCL file in each of your modules and just run a Terragrant plan all, right? And so these small little shortcuts will enable you to act upon massive repository or library of modules. Same for Terraform security. Now you'll see we interrogate this environment variable, this target platform, and we discover whether we are in an AMD environment or an ARM64 environment, and then we install the appropriate version and architecture type of this program, right? This dependency. Same with Terraform lint and Terraform docs, our AWS CLI, our G-Cloud CLI, all of these little tools we install right here. And at the end, we install our pre-commit, okay? Now, up until that stage, we've now got a Docker container. Now, if you go to this library, where you usually have, when you clone your repository, next to it, you will have, this little code spaces thing, tab. Sorry, my English left me there for a second. You have this code spaces tab. And if you click on this code spaces, you can create a code space on the branch that you are at. Now, to save ourselves time, I've already created this. And immediately when I open it, it will look like this. This is my code spaces. So if we click over here, when we go to terminal, we go new terminal, immediately I can look at Terraform-V, and I should just type properly, -V, and we will see that we have Terraform version 1.5.3. Now, I see that I have switched this around, so I've started off with the code spaces. I'm just going to switch this around a little bit and go back to VS Code. Now, if you open up VS Code and you have this extension installed, the Dev Containers extension, when you open up this repository, you will see a little pop-up that asks you, do you want to relaunch this environment in a dev container? And when you click yes, it's going to build this Docker file for you. And again, you can do Terraform-V. And again, it's 1.5.3. And of course it is, because we said that it should be Terraform version 1.5.3. And just to show you that on my own laptop, if I just clear this, if I go Terraform, I go Terraform-V, I actually don't have Terraform installed here. So this is nice, because now everything lives in this Docker component. And when my laptop breaks, or when I need to get a new laptop, or when I'm on a client site, I don't really care. It's just a terminal to work in. And whether I work in an IDE or whether I work in this browser, it all functions exactly the same. Now, this is for our local dev. You don't have to use this. You can still quite happily work on this code base, but it just means that you are going to need to install this yourself. Now, if I show you my Docker containers over here, then you'll see here is my developer environment, my code space actually, and it's Docker PS, and here it is. Now, up until here, we still got an IDE to work in, right? But now I'd like to show you, let's say we want to build this same Dockerfile and use it in our GitHub Actions. Well, we can do that too. So in our GitHub Actions pipeline, and I just want to increase the size for you a little bit. I think that should be a little bit better. Yeah, that looks readable. Now, let's just look at our GitHub Actions quickly. Over here, we have a build and publish stage. And what this will do is it will take our Docker file in this repository, and it will build an image for us. And it will build, let me just quickly see, an ARM64 and AMD container for us. And it will then publish it for us over here in our GitHub container registry. We can publish this in ECR if we want to, or Docker Hub, doesn't matter, right? I just publish it here. Now, after it's published this, and we now want to do our compliance, it will also use this image for us, meaning that the results we get will be extremely consistent, because what we use here in our IDE is what the build agent is using. And so first thing we are going to do is we are going to run run.sh. Now, this run.sh is basically just a bunch of commands that I've created a make file for, which means that if I go make lint, it's actually going to make Terraform lint for me. So if I type that, it's going to run TFLint on all of my files and all of my modules in this repository. Now the make file is defined over here. And I've left you some examples of how to do for loops in your make file. And over here, I've got a method that publishes my Terraform modules from this monorepo to the multi-repo, and then finally gets pulled into Terraform Cloud. And I'll show this to you later on. But if we just look at lint, it's actually just going to do Terraform lint, TF-lint, and YAML lint for us, right? And then TF-lint is much the same Terraform lint, right? So now we are going to go into our second part, which is our compliance and governance. So let's open up our Git pre-commit. Now, pre-commit is a wonderful utility. It's got some rules. I've left you some links at the top, and it's very extensible, and it will just help you so much when you start coding. We are humans. We get complacent. We make mistakes, and I'm no different, right? So first off, this pre-commit is defined in the .precommit-config YAML file. And in here, we have a repository with a version. And these versions are going to be right through this project. You will see these versions come into play. Now it will check for our large files that we can add. So if we add files larger than this, it's going to fail us. It will check for merge conflicts, no new submodules. It will fix your end of line fixer, whether you're on a Windows or Unix type operating systems, Linux. It will fix our trailing and white space for us. And I'll show you an example of this later on. It will check our YAML, it will check our JSON, and it will also detect whether we have AWS credentials in our code. And it will check whether we have private keys in our code. And then Anton Babenko, one of my fellow Terraform ambassadors, has written some pre-commit rules for Terraform. And of course, I'm going to use it because he has just written such great stuff, such a list of Terraform modules that he is probably famous in the Terraform community. So we're going to run Terraform format and Terraform docs. And then down below, we just lint our Docker files. And you can also specify ignore to it. For example, they don't like that you use apt, but I use apt to install packages. And so I just ignore that rule, right? And then afterwards, we have TFLint. And in tflint.htl, you can specify all of your linters that you'd like Terraform lint to do, tflint. And the same with YAML lint, all of these YAML lints. Now, I know some of you are also Ansible, use Ansible in your code, and this dev container with these lints, you could use very successfully with Ansible, and this will also check your pipelines for you. Now, that is it for the config files. Now, I would like to just show you Terraform validate. So if we run make validate, it will run over our code for us. And it will alert you to many, many rules that it will check and see whether your configuration is valid. And in fact, before I do this, I would like to just quickly show you an example. So let's say we go into here, into AWS, and we just go into patterns, or let's go modules, and we have an AWS debug. We open up this main file, and we take this part away, okay? Let's just run make validate. So it will scan through all our modules for us. And then if it finds a problem for us, it will alert us to the fact that there's something that we need to fix. And this is even before we commit a single line of code or wait for a peer review on our pull request to catch these things, right? So let me just quickly give a second. And it will run through all of our patterns and our modules for us. And I thought I'll take one from the top, but apparently it's not the one at the top. And so we just give it a little bit of time. And the rules that it runs through is quite a significant amount of rules. If you just run this on your own modules, you will quickly see the amount of rules that it evaluates your Terraform code to. And okay, so I see that this has not caught that. Sorry, if I just run ./run.sh, let's see if it catches it. It should definitely catch it for us. It could be TFLint actually that is doing all of this for us. So here it will just clone our modules for us. Let's just quickly see here. If I can just quickly focus TFLint. There we go. So one of these battery of tests that it will be doing for us is one of them is TFLint. Now it will tell you that Terraform, you need to add a required version. It will give you a reference and a link of why TFLint is as of the opinion that you should be adding a Terraform version. So it also tells you that you're using null resource, but you have not added this in the required providers. So if we add this over here, and I think I just want to space this weird for us, and let's see if TFEnv fixes this for us. Make format. It's probably see. So one of these battery of tests is also stuff that can fix our syntax for us. So make format will automatically, fix this for us. Just, oh, sorry, it's got the dot there. And so if we run it again, it will automatically fix our syntax for us. Now, if you can imagine how many modules you can have and in your organization of how many Terraform modules you can have and the power that comes with something like this. Now, if I just show you in my GitHub Actions pipeline, that it is also running these battery of tests for us. So if we go to run.sh and we go over here, then you can see that it is scanning our, it's running our pre-commit rules for us, and it's doing Terraform init to pull down our modules, and then it will be doing still Terraform init, and here it is doing TFSec to scan our code, and at the bottom below it, it will do checkoff, and checkoff at the moment prints the things that it's passing, and it will also tell you the things that it is failing on. For example, that you need to have a commit hash when you use a module source. And so, but you can suppress this and you can skip these. For example, the way we do this is if I just show you in my pattern and I go make all patterns and we look at this main.tf, you can see that we can skip these rules. And this will become important when you start developing Terraform modules and you're not just ready to publish these. Now, one of these commands that it will run for us is make docs. And this will use Terraform docs and generate our code for us, meaning that when we go to this repository, let's go here into this repository, and we look at a module. Let's say we look at a module, and we just going to use this AWS debug module. Then you can add some of your own code in this readme. This could be a diagram of what your module is actually going to do. It could be some links that you have, but inside of this, you will have a docs folder. And inside of this docs folder will be Terraform generated code. And this is the same code that you will see on the Terraform registry, how to use your module. So now we've stepped through some of the compliance checks for you. I've showed you the pipeline, and I've shown you I've shown you the builds. And if I show you here, this step will publish our modules for us and push this to its own little repository. And maybe we can quickly I'll go into this in this third section. And then actually this is a good segue to start off with the Terraform modules and patterns library. So there's a lot of duplication that happens in Terraform modules. If you consider git ignore, let's say you're using pre-commit files. Let's say you're using dev containers. Let's say you have TFEnv. All of these files are duplicated. And if you make a fix in some of them, if you have a lot of modules, it could take quite a while to get these fixes checked into your multi-repos. Even worse, if these repositories have owners that does not belong in your team, meaning that you need to make a pull request, you need to wait for it to get merged, go through this whole development life cycle, and then finally your change is alive. And now only you can use this change in your, let's say, your pattern that you are using. So for that reason, as a consultant, I created this Terraform modules library. Now, it's a lot more than just the developer environment. This is one part of it, but another part of it is a QA environment for your Terraform modules. So this structure can be changed, and I just put your AWS, Azure, and GCP, and then custom. And custom could be stuff like Cloudflare. It could be stuff like an Ansible AWX provider. And Azure or AWS has got your modules in here, and then you're going to have patterns. And although your modules have examples, you will most likely end up with patterns that will use a subset of modules and put them all together, and this will be a pattern. Let's say, for instance, a single server behind a load balancer. And now you have an EC2, or you have a GCP, or you ask in your module or your pattern, which cloud would your client like to run this on? Which operating system is this? Is this Windows or Linux? And then which load balancer, ELB or ALB, or how is this pattern going to come about? So for this Terraform modules library just helps you create a development environment that will help you quickly check all of your modules and help them publish it. Now, to publish these modules, when you are ready and you feel like your module is ready for consumption now, inside of your module, we create a .module-version file. And the .module-version file looks exactly, excuse me, like the Terraform-version file or your Terragrant version file. And the benefit of this is that when you are finished developing, you can bump this module here, but it still stays main, or the tags are different of this Terraform modules library than what your actual module will be. So for example, if we look at let's go here to my repositories, and we go into my repositories, and we look at this Azure. I wonder if I pulled that in. Let's use this AWS debug. So this AWS debug has just a small version subset of files, right? It's got a git ignore in here, and it's got the module version file, and this module version file will be equal to the tag that is in here, right? Now, you have to create this repository automatically. You can script this in Terraform. I've not done this, but this repository should exist before you start publishing this thing. What then happens is when you build it, your Terraform modules library will check this in here with its little bit of a documentation that people can use, right? Or it will get sucked in to Terraform Cloud. And if we go here to the registry, you will see that we can then filter on AWS, and you've got your AWS debug. And this is the same version of the version that we specified there in the GitHub repository. And you will have your documentation over here, and you will have your inputs and your dependencies, and you will have your resources, what this can use, and then obviously how you can use this module. Now, this is all based on the semver versioning, and basically semver is just a versioning schematic semver, and it is for major, minor, patch, meaning major is the first part of the dot, and then minor is the second, and patch is the third. And this way, you can keep on pushing updates to your modules, and your clients, your teams, your clients that use your modules can subscribe, or they can choose whether they want to update, right? Or you can notify them what are the changes from version to version, and they can pull this into their dev staging, and out it goes to production, right? Now, lastly, I want to just take you through a run of this repository. So maybe it's a good thing if I show you in here, in GitHub pipeline. I can close this. Here I've got a plan and apply for you on TFC, and some of these variables will become important for you to use Terraform Cloud. I've decided to use the API integration because I find it's more flexible. With the VCS integration, when you push something, it automatically builds, but I would like to run some compliance before, and then do some stuff in between, then do some stuff on TFC, and then maybe at the back of it, run something else, right? So for me, the API integration works really, really cool. Here is some code that you guys are free to copy and use. Thank you very much, HashiCorp, for creating this little GitHub Actions extension, if you want to call it that. And then lastly, I've shown you what a plan and apply would look like. So that's actually the part that fails in my pipeline. It's my own personal account, and I just didn't want to spend these RDSs and resources up, but you are welcome to use these plan and apply for this. Just one thing to note is with Terraform Cloud, your configuration and state kind of goes together. So your configuration directory is what is going to be uploaded in your Terraform workspace, and that will be applied with your state. Right? So if you upload another configuration, it will be removed from your state because the configuration is different, right? And what this then actually looks like is in your TFC, in your organization, in your workspace, you will get some runs, and the runs will look something like this, right? A normal plan. Now, this plan is available in your GitHub website as well. And then lastly, there's a lot of talk, why use Terraform Cloud? Well, it's fairly simple. If you can run Terraform Apply, you can run Terraform Destroy. So I might be giving away my age, but for those of you who remember Johnny Drop Tables hack, well, that means that the user, the database user that used to do your database migrations for you, your schema migrations, used to be used in the web app. Well, now all of a sudden your web app have access to drop tables or do some destructive operations. So for the same reason, we use Terraform Cloud. It's free for small teams. It's got great functionality with a free version, so go and sign it up. But if I just show you over here, here is destruction and deletion, and we can prevent destroy. We can prevent destroy if we untick this. And then lastly, if you have a big team, and if you're going to use this Terraform modules library, you probably have a huge team. So how can you say what is the state of your infrastructure? Where I come from, it was hundreds of AWS accounts, thousands upon thousands of dollars per month, hundreds of developers. It is impossible to interrogate all of your GitHub pipelines or Jenkins pipelines or whatever pipeline to see the state of your infrastructure at play. Well, if we go here, we can have an explorer function. And for TF Plus, Terraform Cloud Plus, there's also a help function, which detects drifts. So here we can see which modules are being used. We can look at what workspaces are being used and which of them have applied an error and the state of them. Friends, that brings me to the end of this Hashi Talk session. Thank you very much for joining us today. Happy Friday to each and every one of you. And thank you so much. I hope to see you again.